Question number 11. A circular deck with a radius of 10 meters is rotating above the water surface to make one complete cycle in 1 minute. A man X of mass 70 kg at platform A jumps on the deck to reach platform B. Calculate the angular velocity on the deck. So, angular velocity, the angle is 2 pi in 1 minute. 2 pi radian in 1 minute. 2 pi radian in 60 seconds. Angular velocity will be 2 pi radian divided by 60. That will give you 2 times 3.142 divided by 60. 0.1047. 0.1047 radian per second. That is A. And for B, calculate the centripetal force experienced by X. Centripetal force, okay, Newton's second law of motion. Centripetal force is equal to mass times the centripetal acceleration. Centripetal acceleration. Mass is 70 kilogram, and the formula for centripetal acceleration is equals to v squared over r. Okay, v is the velocity, r is the radius. So what is the angular velocity? Is it given? Angular velocity is given as from A 0.1047 squared divided by the radius of 10 given in the question, and that will give you 0.076. 0.0767 Newton. Okay, I'm not sure why the answer given 7.67. So that's the answer that I have. Let's move on to the next one. C. Calculate the tangential velocity for X at the edge of the deck. The tangential velocity is equals to angular velocity multiplied by the radius. Okay, your angular velocity is given as 0.1047 radius per second multiplied by the radius of 10, you will get 1.047 and round up to 1.05 meter per second. State the force D. State the force enable X to remain stationary on the deck. So obviously it is frictional force. For question number 12, the next question. A wheel starts rotating initially from rest with a uniform angular acceleration. Complete one revolution after 6 seconds. Determine A, the angular velocity after 6 seconds. For 12A, the angular velocity after 6 seconds, what we have is, we know that the time is 6 seconds. The initial velocity is 0. Okay, they want to know what is the final angular velocity. And we know that the displacement, okay, is 2 pi. the angular displacement is 2 pi. Therefore, if you have learned in Form 5 Physics linear motion, there is a formula that relates all these 4 letters. Okay, S equals to 1/2 U plus V times time. So we can use the similar formula for this. So our S in Form 5 is referring to displacement. Here S here represent the angle, okay, that has been covered, which is 2 pi. That's half. Initial velocity is 0. That's the final angular velocity. That's what we want to know. The time here is 6 seconds. Okay, and you can solve for velocity. 2 pi times 2 divided by 6. That will give you your angular velocity. Angular velocity is 2.095 radian per second. And for B, the angular acceleration. And angular acceleration from linear motion, you also have one formula as such as this. Acceleration equals to final velocity minus initial divided by time. So here the angular acceleration is given by the final angular velocity, which is 2.095 minus initial 0 divided by a time of 6 seconds. And that will give you answer of 0.35 radian per second per second. That's B. C, the angular velocity after 2 revolutions. The time taken for the second revolution, okay, so what you need to do is, you need to find out what is the time taken for the 2 revolution, which is all, minus with the time taken for the first revolution. That will give you the time taken for the second revolution. Okay, so how to find the time taken for all for 2 revolution is using any one of those linear motions formula and also with information from C. Okay, so the time taken, you can use acceleration formula. A is V minus U divided by T. And from C, our acceleration is 0.35. The velocity is 2.97 minus initial 0 divided by time. Therefore, our time is equal to 2.97 divided by 0.35. That will give you an answer 8.4857 seconds, but this is for 2 revolutions. The question wants, what is the time for the second revolution? The second revolution, you need to minus the time taken for the first revolution, which is 6 seconds given. So the time taken for the second revolution is equal to 8.4857 minus 6. That will give you 2.49 seconds. Okay? For question number 13, a belt of length 25 meter runs on a wheel of radius 30 centimeter. The wheel coasts uniformly to rest from an initial speed of 2 rev per second. Calculate the number of rev the wheel turns before it stops. Okay, so you have a wheel. The radius is 30 centimeter or 0.3 meter. And then you have a belt. The length of this belt is 25 meter. Okay. So what is the number of revolutions of the wheel turn before it stops? So what you need to do is 25 meters divided by 2 pi, radius 0.3. So how many rev? 13.26 revolutions. That's A. The angular acceleration of the wheel. For B, the angular acceleration. For B, the angular acceleration of the wheel. Okay, we know that the initial speed, is 2 rev per second, and convert this to angle, it will be 2 pi. Okay, 2 times 2 pi radian per second. Because 1 rev is 2 pi, so 2 rev will be 4 pi. 4 pi radian per second. Final angular velocity is 0. And the displacement here is 13.26 rev. Because 1 rev is 2 pi, therefore 13.26 rev will be 13.26 times with 2 pi. Okay? That will give you 13.26 times 2 times 3.142, 83.33 rad. Okay, rev change to radian. So there is a formula for centrifugal angular acceleration, which is given as v square equal to u square plus 2as. v0, u would be 4 pi square plus 2a times 83.33. And then move them around, you will get 4 times 3.142, square it. Four times 3.142 times square it. Okay, divide by 2, divide by 83.33. Your answer will be a negative 0.948 radian per second per second. That's the answer. For 14, the tires of a Myvi car make 65 revolutions as the car reduces the speed uniformly from 80 to 30. Okay, 65 revolutions. The car reduced the speed uniformly from 80. Initial is 80 km per hour. Final velocity is 30 km per hour. Number of revolution is 65 rev. Okay, the tire have a diameter, radius is 0.4. What is the angular acceleration? So they want to know what is the angular acceleration. For question number 14, the initial velocity, 80 km per hour. Okay, you need to convert it to meter per second. So 80,000 divided by 3,600 meter per second. That will give you 22.22 meter per second. Okay. Similarly, the final velocity is 30 km per hour. Convert it to meter per second, 30,000 divided by 3600. That will give you 8.33 meter per second. 65 revolutions. The car makes 65 revolutions. So 65 rev. That's equivalent to 65 times 2 pi. Okay, 65 times 2 times 3.142, 408.46 radian in angular displacement. Okay, and if you convert it to displacement circumference or arc, the displacement in terms of meter would be 408.46 times with the radius of 0.4. That will give you 163.384 meters. Okay, so since we have initial velocity 22.22 meter per second, final velocity 8.33 meter per second, and displacement, we are using displacement 163.384. So this is S. So what is the formula? We use V square equals to U square plus 2AS. Okay, where V is 8.33 square equals to 22.22 square plus 2 times the acceleration times 163.384. Therefore, when you solve for your acceleration, that will give you 8.33 square minus 22.22 square divided by 2 divided by 163.384. That will give you a negative 1.299 meter per second per second. But because they want to know what is the angular acceleration, okay, angular acceleration, so how much is 1.299 meters converted to angle? Remember, S equals to R theta from circular motion in Form 5 MS. S is the arc length. So what is our radius is 0.4. So what is our angular? What is our angular displacement? This is what we need to know. And S is negative 1.299. So our angular acceleration would be given by S over R, which is negative 1.299 divided by 0.4. 3.25. That's the answer. Negative 3.25 radian per second per second. Okay. And for the last question, number 15. A flywheel has a constant angular deceleration. Angular deceleration, you have a negative in front, 2.0 radian per second per second. There's a negative in front. If the flywheel comes to a rest from an angular speed, so the initial speed is 220 radian per second, and the final is 0. Find the angle through which the rotor turns. Okay, so what do we have? A flywheel has a constant angular deceleration. So A is equals to a negative 2.0 radian per second. Angular deceleration, we have to put a negative. Comes to a rest. Final velocity is 0. Initial angular speed 220 radian per second. Okay, so what is the angle through which the rotor runs? So they want to know what is the angle S. So again, we have the same formula. V square is U square plus 2AS. Okay, 0 square equals to 220 square plus with 2 bracket negative 2.0 times S, the angle. So 220 squared divided by negative 220 squared divided by negative 2 times 2.0. That will give you your angle. Okay, 220 squared divided by 4, you get 1.21 times 10 to the power of 4 radian. For B, the time required. Okay, so what is the time? So again, A equals to V minus U over T. So T time equals to V minus U over A. V is 0, U is 220, A is negative 2.0. So you will get 110 second. That's the answer. Okay, Luqman, hope that you understand our session today. Okay, so teacher did this exercises based on the knowledge in what you have learned in AdMaths, circular motion, as well as in physics, linear motion. Okay, you can modify the linear motion to make it into circular motion.